So if you've practiced manipulating your radical expressions, now we're going to start solving radical equations. So we're going to use this principle of powers. So if we start with the equation A equals B, so I have two things that are the same. Then if I raise both sides to the same power, that's an equivalent equation. Okay? So we can raise both sides of an equation, both sides to the same power, and create an equivalent equation. So think about how we would use that principle to solve the equation square root of x equals 8. Right, so my goal is going to be x equals, right? When you're solving, the goal is to get x equals a number. How would I get to x equals a number if the x is currently, right, underneath this radical? It's in a square root. I need an operation that's going to break that square root, that's going to undo a square root. Right? So the operation that undoes square rooting is squaring. So I would square the left side, but that means I have to square the right side, right, to be equivalent. So squaring the square root gets you the x, and squaring the 8 gets you the answer, 64. Okay. So sometimes we'll have some work to do after we do the power principle. So let's see what that's going to look like. So I have the square root of 3x plus 5 equals 6. So I have a square root equals a number. So here's my x I need to get to, but first I have to break it out of the radical. So to do that, it's a square root, so I need to undo square root. So that means I'm going to square. I'm going to square the left, which means I square the right. So squaring the square root just cancels, and we get 3x plus 5. Squaring the 6 is 36. Well, I've taken the equation, right, that used to look kind of complicated because it had a radical, and now I've made something nicer. This happens to be linear. X is to our first power, and we solve linear equations by, right, isolating the x term. So I'll subtract 5 from both sides. So 3x equals 31, and then we divide by the x coefficient. So x equals 31 thirds. That would be the answer. When we look at our next example, I'm going to show you some strategies, right? So here's my square root, right, with the x in it. There are a bunch of things kind of hanging out on that left-hand side. What you want to do is isolate the radical part before you use the power principle. Now, you might not always be able to get it all the way by itself, but you want to get as much of it, as much of the other stuff moved to the opposite side of the equal sign as you can. Okay. So if I look at this example, 5 times the square root of x plus 4 minus 1 equals 9, the first thing I would do is add 1 to both sides. So I'm going to kind of isolate that term with the radical in it first by adding the other term across. So now I have 5 times the square root of x plus 4. Those guys added away. Now I have equals 10. So my square root part still has a 5 that's multiplying. It would be nice if that 5 were gone. It's okay if it's not, but it's a little bit nicer if it is. So I can get rid of it by dividing the left side by 5. But then we'll divide the right side by 5 to stay in balance, which leads me to, I'll pop up over here. So now I'm at the stage where I have the square root of x plus 4 equals 10 divided by 5 is 2. So a square root equals a number, right? So what do? We need to undo the square root, so we square both sides. So x plus 4, squaring the square root cancels, right? They undo each other. And 2 squared is 4. Okay, so we still need to get x by itself. So now that we've gotten rid of the radical, we still have to solve this equation that's left. So I am going to subtract 4 from both sides. So x equals 0. Okay. This next example, this is going to be a little bit trickier after we square. So I have x equals 5 plus square root of x plus 1. Okay, so here's my radical term. It has this 5, right, this positive 5. I need to move that 5 to the other side, so I'm going to subtract 5 from both sides. Once we do that, we get to x minus 5 equals square root of x plus 1. Okay, so far so good. Now we're to the right. We need to get the x out of the radical, so I need to square the right side to make that happen. So I'm going to square the right, but I also have to square the left. Notice how I snuck those parentheses in there, right? And I needed the parentheses because I'm squaring the entire side, not just the terms on the side. So I need to actually square x minus 5. So maybe you'll use FOIL. Maybe you know the pattern for that. But my left side is going to become x squared minus 10x plus 25. Right side is easy, right? Just x plus 1 because squaring the square root cancel. But now this thing that I have left to solve is quadratic. I have an x squared. We solve quadratic equations differently than we solve linear equations, right? We need to have that set equal to 0 and then try to factor. So we'll go ahead and subtract x from both sides. And we'll subtract 1 from both sides. And what do we get there? X squared minus 11x plus 24 equals 0. Okay, well, let's keep our fingers crossed that that's going to factor. You know what? I'm going to go ahead and skip down here to the bottom on my page. I didn't leave myself nearly enough room. Chink. Okay, so we're going to solve x squared minus 11x plus 24 equals 0. So if you know the quadratic formula and you hate to factor, go ahead and use that tool, but I'll go ahead and try to factor here. So multiply to 24, add to negative 11. I think that'll be x minus 3 times x minus 11. So my potential, I'm going to call these potential answers, x equals 3 and x equals 11. When we have a quadratic equation that we solve in our radicals, there might be a case where we introduce something called an extraneous solution. So I know, stay with me. That means, right, these two numbers definitely work in the x squared minus 11x plus 24. They work all the way back up to this stage right here where we had x squared minus 10x plus 25 equals x plus 1. But they may or may not work in the original, because they might lead us to have this radical either be a negative number, or it might be that, right, it's kind of like the non-principal square root, right? So that negative 1, but we don't actually get the negative 1 because we can only get the principal root. Anyway, we're just going to check. We're going to check both of these answers in the original and see if they both work. So let's check x equals 3. 3 equals, maybe, does 3 equal 5 plus the square root of 3 plus 1? Right? Is 3 equal to 5 plus, let's see, 3 plus 1 is 4, square root of 4 is 2. It is not. 3 is an extraneous solution. I'm going to go ahead and cross that off. 3 doesn't actually work. So my whole part there about the principal root and the other one, notice, right, if we could have gotten a square root out of that to be negative 2, then it would have worked. But we can't, right? We can't just make that whole term negative. So that's kind of why the extraneous comes in. Okay, let's check the next one. So 11, does 11 work in the original? So is 11 equal to 5 plus the square root of, oh, I said 11, Angela. 8. Thank you. It's like I'm not getting something that's a perfect square. Thank you, guys. You should have shouted louder. 8. I can factor. Square root of 8 plus 1. It's a good thing I checked because, right, I was going to have, and this is an 8. Is 8 equal to? Thank you. So is 8 equal to 5 plus the square root of 9? Well, yes, that is a solution. Okay, well, I'm glad I checked so that I knew that it was actually 8 and not 11. Okay, so my solution set is just the number 8. Okay. Oh my gosh. Let's go. One more. Oh no, 3 more. Cubed root of 3x plus 8 equals 5. What operation do you think I need to do to undo the cubed root? Right, we're going to cube. Cube both sides. So cubing the cube root. 3x plus 8 equals 5 cubed is 125. Cubing the cubed root, right? The exactly cancel. You just get that radicand out. What we have is linear x to the first power. So we just isolate the x term. So subtract 8 from both sides. So 117. And then divide both sides by 3. I think that's actually a nice number, like an integer, isn't it? 39. You can use your calculators for sure. Okay, here we go. I have the quantity 6x raised to 2/3 power, and that equals 25. Okay, so let's think of all of your exponent properties. We're trying to solve for x. The x is currently, raised, it's in this expression, raised to a 2/3 power. It'd sure be nice if that power was a 1 instead. So what do we have? What kind of tools do we have? What can I do to the left-hand side of that equation so to make the exponent be 1? Right. Well, remember, I'm going to grab a different color so you can kind of see. Powers to powers, we multiply. So if I raise the left side to the reciprocal, 3/2 power, powers to powers, right? We're going to multiply those two fractions, 2/3 times 3/2. That's going to be a 1. That's nice. So now my 6x is just free and clear. 6x to the 1, we don't have to write the 1. But now if I do the 3/2 power for the left, I have to do the same thing on the right. So I'm going to have 25 to the 3/2 power. Okay, here we go. Left, we talked about it. So I just get the 6x. That's awesome. And then on the right, oh dear, I have 25 to the 3/2 power. So if I do that in radical notation, 25 is my radicand, 2 is my index, then I'll cube my answer when I'm done. Square root of 25 is 5, cubed is 125. So 6x equals 125 is an equivalent equation. Solving for x, we divide both sides by 6. So 125 over 6. Okay, last one. Oh my goodness. Let's see, what would I do on this one? I have a fraction raised to a negative exponent, and that equals 6. I think I might do what I just did before and multiply by the reciprocal. I'm not multiply, but raise both sides to the reciprocal of the exponent. How do you think? Should we try that? Okay, so I'll copy it down here so we can see. So I have x to the 4th, and that's raised to the negative 1/2 power, and all of that equals 6. So my left side, I'm going to need to raise to the negative 2, right, if you want to stick a 1 under it, so negative 2 over 1. And then I'm going to raise my right side to the same thing, right, same thing to both sides. So 6 to the negative 2, negative 1/2 times negative 2. Just make sure you're okay with that. Right? Everything cancels, and a negative times a negative is a positive. So these exponents, when I do my power to power, I just get x over 4. Now I have to deal with the right side. I have 6 to the negative 2. Well, what's 6 to the negative 2 equal? 6 to the negative 2, right? We do the reciprocal of the base, so 1 over 6 squared. So that's going to be 1 over 36. Okay, so I'm going to do that. So 1 over 36. Boy, now how do we solve that one? I want to get the x by itself, and right now I have x divided by 4. Right? So I need to move the 4, right? And it's attached with division. So to undo that, I multiply both sides by 4. So x is all by itself finally, and I have 4 over 36. Or if you reduce that, 1/9.